My idea talk today is going to be about making geodynamics more of an extroverted type of science, especially the products that CIG has generated over the years. So CIG has been developing many codes, and those are always very useful, they're very important, and it's actually quite diverse in the application, as what we can see in this gallery of what has been produced by CIG. The thing, though, that I would like to address here is that these are really introverted code in the sense that they were developed by geodynamicists and allied people, especially in applied math, for the use of the geodynamicist. These codes are meant to address fundamental questions in our science. Maybe it is time to actually change a little bit of attitude and to look outward instead of inward towards what would be the next steps, the next development in CIG and in geodynamics in general. Maybe we should be thinking about making codes that could be used by a broader community than those people that just called geodynamicists and applied mathematicians. Maybe they could be more application focused so that they can be used really for hazard assessments or to have a very strong link with geological data. They could be, if that is the case, if we start to looking outward, they will be very much able to support additional studies, like for geochemists to use an actual interior model from geodynamics, for someone who's looking at a sedimentary record to use a geodynamical model to make a tighter link with climates in the past, etc. The one example, though, that CIG has done very well on this is certainly SpecFem, which is used by the seismological community. It is not just made by the geodynamics, it is certainly having a broader reach. So one recent example of what can be done with this approach has been published, for example, by Anna Glerum and others earlier this year. They have developed a model of the Victoria continental macroplate in the East African Rift. And this model can be compared with, is based on the geology, it can be compared with GPS and stress measurements in the region, which is very useful. To do this, they had to use a very complex geometry, which is not a trivial thing to do with most of our models, with this kind of wavy rift, and to make them more and more geologically realistic is actually very hard. And to a very large extent, you really need to involve people who are very familiar with the field, with the constraints, but because we only have so much time, maybe it would be good if these people could be the one actually doing the application, the models for the place of their own interest. What are the problems with this? Well, let's face it, our codes are not that easy to use. They are based on scripting, and you need to learn a programming language. It would be much better instead to have something which is more graphically based so that we first get a feeling to what we can use the models for before having to invest into learning a whole way of talking to those software. They are still quite hard to install. Even Dockers and things like this are not a perfect solution. I know we've been working on it, but it's not that there yet. Access to computing resource is always difficult. It can be very expensive to run some of these models, especially in 3D. And a person who is not making a living out of a geodynamicist, they're not going to have a very fancy equipment, and they may not be able to write the correct applications for getting access to shared resources like TAC or stuff like that. And because of the design of the model, it is very difficult to have a very realistic type of setup like what I've showed earlier in Anna's paper. So what do we need to enable this extroverted geodynamics? Well, we need to make the codes easier to use. Like I said, graphical user interface so that you can do it without learning a whole new language would be very important. Easy to install. Commercial codes, we do a lot of what I'm describing here. Those give you executable. They don't give you, source codes or stuff like that. So it is just like usually point and click, it's packaged things that you can just install on your computer. Because the computing resources, people may not have it. We really need to have those software pre-installed on supercomputer because you can't expect anybody to actually do it on their own. Someone who's not 100% of their time, spending 100% of the times on these problems. And maybe even on-demand cloud computing could be very important for a lot of people. And we have to enable the realization of increasing realism, like this model of Southern California that I'm showing there. This geometry is extremely complex. It's not going to be possible by hand to find out every single node. Maybe linking with community database of topography or the one I'm showing here could be very important for a lot of problems. So I think by this talk, I've encouraged you to really think about how to turn geodynamics from an inward looking to an outward, an extroverted branch of science. Thank you.